So let's do a couple of examples of production. This is chapter 6. So here we have a chair manufacturer which is producing, and the question is calculate the marginal product of labor and the average product of labor. Okay, so to get the marginal product of labor, we know marginal product is the additional output as you add one more labor. Okay, so here we go. We have this one. We don't have any value because there's nothing in front of 0. So here's the difference between these two. The difference between 10 and 18. That's the marginal product of labor. Because why labor? Okay, we're working with number of workers. So the input that is changing is workers. So we can say that capital, which is not indicated here, is the fixed input because we're working in the short run. Okay, so the marginal product of labor in this case is then 8. The following one is the difference between these two, which will then be 6, and then it is 4, then we have 2, and then we have minus 2, and then lastly we have minus 3. Okay, and then the average product. So the average product is the total output, total number of chairs, divided by the number of workers, okay, or the inputs that we needed to produce that. So 10 divided by 1 is 10. Then it's 18 divided by 2, that is 9. Then we have 24 divided by 3, it's 8. And then it's 7. 30 divided by 5 is 6. 28 by 6 is 5. No, sorry. 28 divided by 6 is, that is 4.6, 4.6, 4.67, 4.6. And then this one is 25 divided by 7. Let's get the calculator again. 25 divided by 7, and we have 3.5, 3.6, 3.6. There we go. Okay, so the next question is, does this production show diminishing marginal returns to scale, or diminishing marginal product of labor? Okay, and then the answer would be yes, it does. Look at the marginal product. So every time we add one more worker, we get a lower marginal product. So that's diminishing marginal product of labor, and then it also goes into the negative. Okay, so the following question, we have a production function, which means that our output is determined by 3 times the labor plus 2 times the capital. Now we want to know, does this production function exhibit increasing, constant, or decreasing returns to scale? Okay, so what does increasing, decreasing, and constant returns to scale mean? Simply meaning, if we double our inputs, will we also double our output? That's basically what it means. So if it doubles, exactly doubles, it's constant. If it more than doubles the output, it's increasing. If it's lower than double the output, then it's decreasing returns to scale. So let's say labor equals 2 and capital equals 2. Now what we're going to do is we're going to get a value. So we're going to get a production output, and then we double this. We double our input. So labor equals 4 and capital equals 4. And then we're going to see what the value is, what our values are. In terms of the output, did it also increase? So we say quantity equals 3 times 2 plus 2, and then capital is also 2. So this gives us a value Q equals, so 3 times 2 is 6 plus 2 times 2 is 4, so that gives us a value of 10. Okay, now we do the same, we double our inputs, so that means Q equals 3 multiplied by 4 plus 2, and then our capital is now 4 as well, so that means it's 3 times 4, it's 12, plus 2 times 4 is 8, so that gives us a value of Q equals 20. Okay, so what's the answer? So the initial output, initial output is 10 with labor to capital 2. We doubled that, okay? We doubled that and it increased to 20. So it's exactly double the initial output that we have, and we doubled our input, so that means we have constant returns to scale. Okay, so that's your answer. So if this value here, 20, was 18, given the inputs that we provided here, that means it would have been decreasing returns to scale. If it was 22, for example, then it would have been increasing returns to scale. So you need less or lower amount of inputs to have a higher output. Okay, last question. We have our production function, which is the quantity produced is determined or explained by the following function: 100 times K to the power of 0.8 and labor to the power of 0.2. So the question is, we begin with a capital input of 4, so that capital is 4, and labor is 49. Labor is 49, so that L is 49. Show that the marginal product of capital is decreasing. Okay, so it's decreasing. So that means we need to show one of this is decreasing, which is the capital. We need to make one of them fixed to do that. So to be able to show if capital or if labor is increasing or decreasing, we need to actually make one of them fixed. So what we're going to do is we're going to say, sure, so quantity equals 100 multiplied by K, which in this case is 4 to the power 0.8. Just copy and paste that one. 0.8, and then multiplied, let's do that, no, 0.8 multiplied with labor. In this case, labor is 49 to the power 0.2. Okay, so first let's just put that in and see what the values that we get. What's the answer? So let's just get our calculator. So we get an answer of 660.2822. Sorry, 22. Okay, so what we're going to do now is we're going to increase the capital input to see if the marginal product of capital is decreasing. So that means capital is now going to be 5. So let's do the same equation again. So just copy and pasting. So that one we're going to do, copy, paste. Okay, so instead of 4, I'm now going to insert 5 there. So labor stays constant because we want to get the marginal product of capital. So that means to get marginal product of capital, we need to fix labor and then change the amount of capital in this equation. Okay, so now we are going to make capital, we're going to increase the quantity of capital and keep labor constant because we want to get the marginal product of capital. So we are going to keep, we're going to change the quantity of capital to 5, so we insert 5 into the equation, but labor we keep constant to get the marginal product of capital. So now our value is going to be 789.25. There we go. So now we do it for capital with a value of 6 make that 6. So we can see our output is actually increasing. So what the value of output now will be 913. Let me just check it down here. 0.19. Okay, so this is our total output. So now if you want to check if the marginal product of capital is increasing or decreasing, what do we have to do? We're looking at the output because we've changed the capital input. Now we look at the values of the output and the change in the values of the output. So the first one, let's have a look. Let's click here. So it's 789.25. We're minus 6600.22. 129. So the first one is 129. 129.03, and the second one is 913.19 minus 789.25. So the marginal product of capital 123.94. 123.94. Okay, so we can see just by looking at changing the capital from 4 to 6, we can already see the marginal product of capital. The marginal product of capital is decreasing.